Hello and welcome to today's ASK Online Academy's webinar, Zircon Free Coatings. The speaker for today's webinar is Dr. Reinhard Stötzel, who is my best experienced colleague in the field of refractory coatings worldwide, and he is part-time supporting us for topics such as this webinar. My name is Christian Koch. I'm the responsible product manager for coatings in Europe, and I will guide you through today's webinar.
Welcome also from my side, and thank you very much, Christian, for the kind introduction. I would like to present you today, first of all, the agenda. How can we share the coating knowledge? Then coming from the idea to practice, showing you some case studies and how to maintain the quality, and finally, the conclusion. Coatings are secondary consumables which provide you as a foundry man with a more stable, profitable, and defect-free casting process. Why is that the case? Because the raw materials and the process have some variations, and this lead to the unstable process. As you see on the bottom, you can have casting defects like veining, burn-in, burn-on, scabbing, gas defects, or even slag defects. Coatings are mixtures of refractories applied on those areas where metal is in contact with the mold and core. A coating is a mixture, a suspension of a refractory, a milled refractory, in a liquid carrier. And to prevent any sedimentation, you need some suspension agents, and you need a binder that you have a good bond strength on the coating layer. And finally, you need also some coating additives which provide you with the features for the right application. As you as foundrymen know, there's different applications available like dipping, flow coating, spraying or brushing, and also different types of coatings available as powder, alcohol-based or water-based coatings. If you need more information or details on coatings, you can find it on our user manual or on our application videos on our website. To select the right coating, we need some basic information. So it means we need to have a good exchange of information between you as the applicant and us as the supplier of the coating. So at least we need to have some information about the scent, about the binder, about the metal, and how you apply the coating. If we do that, then we could select the best selection for you. And these kind of checklists are available on our homepage. If we select a good coating, certainly you can save a lot of money. Even coatings are an essential cost factor. They provide you with value added. If you select an unsuitable coating quality or an incorrect coating application, you result in increased fettling costs or even scrap. If you apply a proper coating quality, you can have much less of these costs. So finally, we estimate that it would be possible for you as a foundry to get at least 3% more margin if you select a good coating instead of any coating. What are the refractories which you can use in steel castings? Certainly, Zircon silicate is the most popular refractory used for steel castings. It has a high density, high melting point. The morphology of the grains are sub-rounded, and from the nature of the refractory, it is an acidic refractory. There's also other features which are not so nice. That is the radioactivity, and it is a natural mineral, so you have certainly also some variations in the quality. Then there's another refractory, which is magnesium oxide, also having high density and high melting point, but the morphology is subangular, and from its nature of the refractory, it's basic. And the other feature is that this material hardens with water. So you can only use the magnesium oxide coatings as alcohol-based coatings. And it's again a natural mineral, but in this case, it's calcined. And then we have alumina, also having a high density of around 4, high melting point of 2050 degrees, which is far enough for steel castings. The morphology is angular, and the beauty of this material is that the refractory is neutral. The interesting point is also that it's a synthetic refractory, and there's a lot of various grades available nowadays. And there's also possibility to use olivine or mullite as refractory, but only for niche applications because it's not so widely applicable. Of course, if we select a coating, we have to consider reactions between metal and coating. This you can deduct from the Ellingham diagram, which you know very well as foundrymen. Of course, we also have to consider a reaction between slags and coatings. In this case, you can see a reaction of the basic slags of manganese steel with the SiO2 of the Zircon silicate, which lower the refractoriness of the coating very much. As you see, the melting point of this eutecticum go down to 1300 degrees or so. And we have to consider a reaction between the sand and the coating. Even if you have two high refractory materials like chromite sand and Zircon silicate, a solid phase reaction can take place. And in this case, the iron oxide, FeO, can react with the SiO2 of the Zircon silicate and form the low melting firelight. And last not least, there is a rim zone reaction of the binders of the sand and the coating. For instance, we may have sulfur pickup in the rim zone. We have decarburization or recarburization. If you have an acid-set binder system, the SO2 or SO3, which is formed during the pouring process, can move towards the rim zone and make a reaction, and sulfur is absorbed. In the rim zone, as you can see here, this is a straight Zircon coating, but if we implement some sulfur absorbing components like a scavenger, the sulfur does not anymore enter into the melt. The other possibility is, of course, if we apply a sealing coating on the sand, the transport of the gases are, let's say, reduced, and there's also no possibility that these reactions can happen. How to come from the idea to practice? We have very sophisticated instruments in our laboratories. For instance, doing rheological measurements or measurements with a tensiometer to control and adapt the flow behavior and the wetting behavior of the coating. And if we do it in a proper way, the coating can cover even an intricate and very complex core packages, as you see on the right side, like a second skin without any flaws. And we are testing the refractories with different castings. We have two pilot foundries, one in Germany, the other one in the States. And in this case, you see step cone, which is coated with a coating, then inserted in a mold, poured, and then we can rank the casting result. The development of this new coatings for steel castings have been done in the States, and you see here what we have done. There are furane compression cores made out of silica sand of AFS 52 to 55 with a furane binder at a 1% level addition and 0.4% catalyst. We tested different coatings, 2 Zircon-based coatings and 1 alumina-based coating, which in this case contains a small amount of Zircon. And we applied it almost to the same coating layer thickness by dipping, as you see on the pictures. After that, these dried cores are inserted in a so-called 2x2 mold, which show a relative high metal to sand ratio so that we can, let's say, adapt the situation like you have in the foundry. Then this mold was poured at 1600 degrees with a flow rate of about 2 kilograms per second. And the castings have been sectioned and ranked. As you see here, the Solitec ST502 shows really an excellent performance. There's no burn-on or other defects compared to the Zircon-based coatings, which we have compared with. You see here, very nice and clean, and here are some defects. To show you the portfolio of the Zircon-based coatings we have in our company, there's Solitec IM801. This is an impregnation coating based on water and Zircon. We have a cover coating ST901. And then in the States, we have the ST903. On the alcohol-based coatings, we have Velvacoat IM801, an impregnation coating based on alcohol and Zircon. And as a cover coating, ST701, or in the States, the CA9078. And for manganese steel, we have the Velvacoat ST802, and in the States, MST703. What is the problem with the Zircon? I don't have to tell this story to you as a foundry man because you are suffering on this situation. Every, let's say, 7 years or so, we have peaks, tremendous peaks in the price development of Zircon, up to 200, 300%. So the prices really go through the roof, which is not nice for you, but also not for us. And in addition, there's also sometimes some shortage. The other odd situation is with the radioactivity of the Zircon. The the genesis of the mineral million years ago provide the sources with some trace elements like uranium and hafnium, which is radioactive. So Zircon sand and Zircon floor have some radioactivity, as you see here. It has 0.7 millisieverts as a dose, and this is comparable with diagnostic radiology and nuclear medicine. So certainly you have to take precautions using Zircon. The other bad situation is if you bring the drums of the coating to the scrap and a truckload of this scrap is going to the scrap dealer, he may refuse it because the Geiger counter makes alarm and you have a big problem then. So this was a motivation for us because these kind of price changes in the Zircon price always happened over the decades. Since I can remember, we have this situation, and this is almost over 40 years when I started in the foundry business. And we came up with the idea to use the alumina. In the past, the alumina qualities were quite so-so, but nowadays we are capable to select a really good, suitable, and high quality grade of alumina. And this led to the portfolio we have now as Zircon-free products, which is a Solitec IM702 as impregnation coating, water-based, Solitec ST802 as cover coating, ST502 as we have already seen as cover coating from the US. We have for heavy iron a Zircon-free Solitec HI604, and the alcohol-based coatings are AM701 impregnation coating based on alcohol, the cover coating ST616, and for the states the ST704TT, and for heavy iron the Velva coat HI733. What's about the benefit of the alumina coatings further? This is certainly the mileage. Mileage is a measurement how many square meters of sand you can coat with 100 kilograms of coating. If we consider the same layer thickness, the mileage is inverse proportional with the density and proportional with the dilution rate. To give you an example, if we have a Zircon-based coating with a density of 2.02 and a given dilution for the application of, say, 14 weight% of isopropanol, we end up with 67 liters of coating. If you use our new alumina-based coating, the density is only 1.85, and at the same dilution rate, we end up at 72 liters coating. This means 17% more coating and 17% more mileage. So a huge cost saving for you as a foundry. Coming to some case studies. Here you see a casting, and we pre-impregnated the mold on some hotspots, especially under the risers, for instance, with Velva coat IM701 at a viscosity of about 12.5 seconds. And then we applied the cover coating Solitec ST802 at 14.5 seconds about. The first cover by flow coating, we achieved 200 to 250 microns, and after mat time, A second flow coating was applied, wet and wet, and we achieved in total 450 to 500 microns. After drying at 120 degrees for 30 minutes, the mold was closed and poured with alloyed steel, DIN 1.6570. The pouring temperature was 1588 degrees and the casting weight about 600 kilograms. And as you see on the casting, there's no flaws, and even under the riser, there's no burn-in. The other case study I would like to show you is a rail wagon casting. It is a side frame and the balsa. Here we applied the Velva code ST616 with a viscosity of 14.6 seconds, and we achieved 250 to 275 matte layer thickness. And the casting results are good. And here an example from the States. Here we see again railway castings, a coupler and a knuckle by flow coating with a Velva code ST704TT at a density of 40 degrees per May. And you can see on the right side the flow coated casting of the coupler before it was sprayed with a Zircon-based coating, and you can see the huge improvement which was achieved. And here the knuckles, you see the same result, very smooth and very nice casting without any defects. And here's another case study. Thank you very much, KSB, for providing us with the pictures. We see a pump impeller made out of cold box, and this was dipped in a Solitec ST802 with a viscosity of 13.5 to 14 seconds and a large furane Norbeck core, which was brushed at 90 degrees per May. So you can see that it is possible, even for complex steel castings, to apply these new synthetic refractory coatings which we have developed. How to maintain quality? Certainly, the impregnation coating is an interesting feature. As you see on the left picture, on a conventional coating, the coating only soaks in the voids, let's say 1 or 2 millimeters, whereas an impregnation coating, dependent on the viscosity, soaks in 5 to 20 millimeters. And you can imagine where the coating is, no more any metal can penetrate and burn into the sand. To a certain extent, it also forgives a bad compaction. As you see here on the right side, the coating soaks in much deeper compared to a good compacted core. To measure the quality is key. You need to measure it by a flow cup, the viscosity, as you see on the left side. In addition, maybe you can also measure the density. We recommend a gravimetric measurement with a graduated cylinder and a scale instead of areometric measurements like with a Baume stick, because the gravimetric measurement is much more precise. And there's also inline measurements available. If you are interested in these things, of course, we can provide you with some information. Finally, of course, the matte layer thickness measurement is important because the layer thickness determine the protection of the coating to the metal. The monitoring and reporting is also very important. Better to measure always two independent parameters, because then you can proactively identify if there's some process variation. Coming to the conclusion, with a new synthetic alumina-based coatings, we have a big advantage in the mileage, up to 20% more efficient than a Zircon-based coating. And you have a big advantage on the price situation, because the prices for alumina are stable and the availability is much better compared to the Zircon silicate. And last not least, we have the benefit that we don't have any radioactivity in the material. Thank you very much for your attention, and I'm open to answer your questions.